Welcome back, everybody. In this video, we're going to continue with solving equations here. I'm just going to call it solving equations part 2 and just kind of kick it up a little bit, go to maybe 2-3-step problems now instead with our solving rules. So I just have a quick recap here. So I'm going to call this solving equations part 2. Again, don't forget to put your date in, or at least the week that you're working. And from the last video, we talked about two main rules, and that was the addition property and multiplication property of equality. And basically what they both said is that it's totally fine to add, subtract, multiply, or divide on both sides of the equation. Again, as long as you do it equally, once to the left and once to the right. With multiplication and division, you just have to be careful that we're not using 0 there. And the other thing we talked about is that when we're solving, our goal is to always get the variable alone. So you kind of want to just keep that idea in the back of your mind as you're solving. Now, we're going to look at some slightly more complicated examples here. Again, still relatively basic. I don't want to say they're super easy because they're not. But, you know, 2-step, 3-step, kind of just kicking up a little bit at first. And one tip, I am going to put all the rules kind of together in a little bit, but one tip is to always simplify each side of the equation first before you do anything else, if you can, of course, if possible. So sometimes when we get to more complicated problems, the biggest thing is actually you just need to simplify first. That's kind of the hardest part. So you want to look at each side of the equation and see if you can do anything first before you start canceling and moving everything around. So let's look at an example here. So my example is x minus 2 equals negative 4 plus 10. So a little bit more complicated than our last video, but not too much more. So I'm still going to start by just drawing that little line in just so I can see each side of the equation. And I'm going to go through my tip first each time. I'm going to look at my equation now and I'm going to see, okay, is there anything I can do first? Keep in mind, you have to watch for like terms. So if I look on the left side of my equation here, I cannot do x minus 2. I can't put those together. So there's nothing I can do on the left side. But on the right side, I do have like terms there. I have a negative 4 plus 10. So I could actually simplify that, right? Negative 4 plus 10 is positive 6. So I'm going to go ahead and simplify this first. Now that I've simplified it, hopefully it looks familiar to you. This is a one-step problem now that we saw in the last video. So now that everything is as simplified as it can go, I'm going to start moving things around. I'm going to start canceling things out. So that canceling and the moving stuff should be done after you've tried other things first, other simplifying techniques first. So I want the x by itself. I want to move this negative or this minus 2. And to cancel it out, I'm going to add 2 to both sides. Negative 2 plus or minus 2 plus 2 is 0. So then I have x is equal to 8. Now, just like before, I'm not going to do every check, but you can go back and check your values by going to the original equation. If I plug in 8 here, I get 8 minus 2 equals negative 4 plus 10. Well, 8 minus 2 is 6, and negative 4 plus 10 is also 6. So it does check out. When you do your checks, you do always want to go back to the original example. That's really important because then if you don't go to the original example, then you may have made a mistake along the way. So you always go back to the starting point. Oops. Changing my variables. Let's make these both y. Sorry about that, guys. All right, so 3y minus 7y equals 12. So I'm going to just draw my little equal sign in first, and I'm going to use that tip. I'm going to simplify each side. So if I look at my right side here, there's nothing I can do. It's just a 12. But if I look at my left side, I do see I have like terms. I have a 3y minus 7y. So what I can do is I can change my subtraction to addition, and then change the positive 7 to a negative. And then I can simplify this part first here. So when I look at it 3 plus negative 7 is negative 4. So I have negative 4y, and then equals 12. And again, now you can see that you have a one-step equation left, or as cleaned up as we can get. There's nothing left we can do on each side. So now I want to get that y by itself. To get rid of this negative 4, the opposite of multiplication is division. So we're going to divide it out on both sides. Negative 4 divided by negative 4 is 1. 1 times y is just y. So I get y equals negative 3. Now, I'm just going to do one more check here. Go back to the original. So 3y minus 7y equals 12. Anytime I see a y, I replace it with negative 3. Here, 3 times negative 3 is negative 9, minus 7 times negative 3 is negative 21. Subtraction becomes addition, negative becomes positive, and then you do get that 12 equals 12. So it does check out. Okay, x over negative 2 equals 10 minus 3. Now, in a few weeks, I will actually tell you how another way you can deal with fraction problems, particularly as they get more complicated, but this one's still relatively simple, so it's easy for us to work with. And I'm going to simplify each side first. So on the left side, there's nothing I can do there, but on the right side, I do have a 10 minus 3. Those are like terms, so I can simplify that to 7. Notice that I'm giving myself lots of room to work. You want to make sure that you don't get too messy here. You want to make sure you stay nice and lined up, or else you will probably get a wrong answer. So it is important to stay organized in math class, really important. So write bigger than you probably normally would, give yourself more space than you normally would, and I think you'll find that your work will be that much better just from staying more organized. Now, once everything is cleaned up, I do want to get that x by itself. So the way for me to cancel dividing is to use multiplication. So I multiply both sides by that negative 2, and I get x equals negative 14 for my final answer. And again, you can go back and check this. Negative 14 divided by negative 2 is 7, and then 10 minus 3 is also 7. So you're going to get a true statement there. Okay. This video, I'm basically just doing lots and lots of examples so you can see, different procedures and things like that. All right, let's kick it up a little bit here. So 5x plus 2 minus 4x equals 3 minus 12. So I'm going to draw my line, and I'm going to clean up on each side of the equation. So on the left side here first, I do see a 5x and a minus 4x. I see like terms. Now, don't forget, if the subtraction signs are throwing you off, you can always change them to adding the opposite. So I can make that change here as well. 5 plus negative 4 is 1. So I have a 1x. And then I'm just going to bring down the plus 2. So that became that. And then over here, again, if those minus signs are throwing you off, then what you're going to do is change it to addition and use the opposite of the next number. 3 plus negative 12 is negative 9. Now, 1x is actually the same thing as just x, right? 1 times x is x. So I can simplify this to just x plus 2 equals negative 9. And then hopefully now this is an example that looks familiar. I want to get the x alone. So to cancel a +2, I use a -2. And notice I'm not moving things around until I'm sure I've simplified everything first. So you want to simplify before you begin kind of rearranging stuff. -9 -2 is the same thing as -9 plus -2, which is -11. And again, I can check my values by plugging it back in and solving there as well. All right, let's do another example. So maybe I have 7y minus 8y is equal to 5 minus 10. First step is to clean up each side. I have lots of like terms here, so here these two can get combined. And again, if that minus sign is throwing you off, you're going to change it to plus, then a negative, so adding the opposite here. So 7y and -8y is -1y. And over here, again, as you get more practice, you'll become more comfortable with those minus signs and just recognize them as negatives. But until then, do your change. So here, -10 plus 5 is going to be -5. Now you have a -1 there that I do want to get rid of. So everything is cleaned up. I want that y by itself. I do need to get rid of a -1. It's not, it is something, so it needs to go away. So I divide by -1 on both sides. That cancels to give you just +1. So I have y is equal. -5 divided by -1 is +5. And again, I can check those values by plugging them back into the original problem. Okay, so let's do another example here. So again, these are all solved. I've kind of stopped writing the word in. I apologize. So they're all solved. 3 times 3x minus 5 is equal to 10x. All right, so I'm kicking it up a little bit again now. And I see a parenthesis here, but it doesn't change how I start. You're still going to look at each side of the equation and try to clean it up. So on my right side, I don't have anything I can do there, but I do have lots of stuff on the left side. I know that I can use the distributive property to begin. So I'm going to go ahead and multiply through. So I have 3 times 3, which is 9. So I'm going to be left with a 9x. And then 3 times a minus 5 or a plus -5 here is going to be a minus or a -15. Now, this is starting to get a little bit different here. So you may be looking at this saying, well, we haven't done this before. I have x's on both sides. What do I do? And you want to think about like terms. So if we have things that are the same, they have to go together. So we do want to get these x's together on the same side. Now, it doesn't matter which way I bring my x's, if I bring them to the left or if I bring them to the right. Here, notice that all I have on the right side is an x term, whereas on the left side, I have two things. So it's actually going to be easier for me to bring this 9x over to the other side with the 10x. And to do that, we're going to use our canceling techniques here. So if I want to get rid of this 9x on the left side, well, the opposite of having a positive 9x is using a negative or a minus 9x. And that addition rule of equality can be used with variables as well. So when we want to move things to different sides of the equation, we can still use that adding and subtracting technique that we did up here as well, right? Subtracting 2 on both sides. And we can also use it with our x's. So 9 minus 9 is still 0. It's still going to cancel out. So I have, let's see, -15 left. Be careful, that minus sign is a negative. And 10 minus 9 is 1. So I have 1x. But 1x is the same thing as x. So here is my final answer of -15. And I'm going to do just a couple more examples here, and then we'll wrap up this video. All right, so I have 2x minus 4 equals 10. Now this one probably looks a lot simpler than we've seen. And it is in a lot of ways, but we actually have to use 2 steps here. So first thing, if you look at each side of the equation, there is nothing to clean up. So I can't really simplify anything here. So I want to start rearranging. We need to get our like terms together. And in this case, the problem is that my 4 is on the left side and my 10 is on the right. So what we want to do is we want to bring this minus 4 to the other side. So I want to cancel the negative 4 on the left, bring it to the right. Notice I'm using minus and negatives interchangeably, okay? So subtraction sign and adding in a negative are the same thing, so we can use them interchangeably. So if I want to cancel my minus 4, the opposite is to add 4, and we're going to do it to both sides. So I have 2x on the left, 10 plus 4 is 14. I still want that x by itself. Here it's a little bit different though. I'm multiplying by 2, so I'm going to divide by 2 on both sides. So x is equal to 7. So notice I actually use both rules in one here. I use the adding rule for equality and the multiplication rule for equality there. Oh, I'm switching colors, that's all right. Let's try another similar style one because these are really popular examples. Again, I look on each side and I don't really see anything I can do. So I have to start rearranging. And I want my like terms together. So I would really like the 17 and the 2 to get together, but they're on different sides of the equation. So I have to move it. I need to cancel the 2 on the left and bring it over with the 17. So positive 2 becomes a minus 2. (17 minus 2 is 15. Now I see that I have a 5 times y. So if I want to get rid of that 5, I'm going to have to divide both sides by 5. And I have y is equal to 3. And again, you can always go back and check here by going to that original problem. If I plug in 3 for y, you can see pretty quickly that you get 5 times 3 is 15, and 15 times 2, plus 2, excuse me, is definitely 17. So this does check out. All right, let's do one more example of this style. I'm going to mix it up a little bit. I'm going to put my variable on the right here, but we're still going to use the same techniques. So I can't really do anything on either side to simplify. So I have to start getting my like terms together. Now, if my n is already on the right, let's move our numbers to the left here because we want the n by itself. So it's easier for me to bring the 5 to the other side then. So this is a minus 5 or a negative 5. So you're going to use a plus 5 to cancel. Negative 20 plus 5 is negative 15. So I have a positive 5n left over. And then now I'm going to go ahead and divide by 5 to get the n by itself. So our rule so far is really to think about simplifying first. So look at each side of the equation first. Can you simplify anything? Do that. Once that's done, you still need your like terms together. So you may have to move things from one side to the other to get those like terms together. And that's when we're using that adding and subtracting. All right, I'm going to do one last example in this video. And this is a harder example, just to kind of give us a little bit of a challenge here. All right, so kicking it up a lot here. So this is a good time. If you want to pause the video, give it a try, see if you can figure it out. But your first step is that tip. Look at each side and simplify first. So notice here on the left side, just looking at the left side first, I do see subtraction, so I'm going to make this adding a negative 6. And I can go ahead and simplify that, right? 2 plus negative 6 is negative 4. So I'm going to clean that up. On the right side, I do see the distributive property. So I'm going to take that -5 and multiply it throughout. -5 times x is -5x. And -5 times +4 is going to be a -20 or a plus -20. That's fine. I'm going to bring down that -39. Now the left side has nothing to do, but the right side still has some work. I still see like terms here that I can combine. So this is a plus -20 and a plus -39. So if I add those, oh sorry, I forgot my x. If I add those together, I have a plus -59. Okay, now I look again and I can't see anything else. So I've kind of cleaned up everything I can. But I still have like terms that are just on the wrong sides, right? I have a -4 and I have a -59. Those are both numbers. They're both constants. I want to get them together. Notice that my x's are already on the right. So if I want to get the x's alone, I also have to think about where my numbers should go. And if my x is on the right, then let's move our numbers to the left. So -59 becomes +59 as I move it to the other side. Notice that I'm only using the opposite sign when I change sides. So the way I think of this is opposite sign, opposite side. So I'm trying to move it to the opposite side. Or I think of it as change sign when I change sides. Okay. So if you're just combining like terms and you're just cleaning things up, you're not moving things from side to side. You're just doing what it says. If you're actually ready to go over the equal sign, then you're using the opposite. So negative becomes a positive. On the right side, I just have a -5x. On the left side, I'm going to end up with a positive 55. Finally, one last step. We want to get the x by itself, so I got to divide out this -5 here. And I have x is equal to -11. Now this is fine here. If you don't like writing it backwards, you can also write it this way. But in either case, we get that same example. So that last one was kind of more of a challenge one for this video because we haven't seen anything with that many steps. We've kind of been sticking to like 2 or 3 steps here. But this is where we're going. So you should be able to solve something like this by the end of the videos for equations.